En satsning som vi gör här i Slite, den kommer vara nödvändig för att samhällsbyggnadssektorn ska kunna bygga fullt ut klimatneutralt. Det är ett stort omställningsprojekt. Vi ska i princip bygga nästintill en ny fabrik till fabriken för att kunna omhänderta uppemot 1,8 miljoner ton koldioxid varje år.
So, okay, I'm supposed to give a presentation about FutureCem, which is the calcined clay limestone cement which we developed in Denmark and is now selling actually in the Danish market. And just to start, what you see in this picture is the limestone, the chalk, grit, which we are excavating in Aalborg in this lake as a raw material for our cement production. And this is actually a very pure limestone, 95% calcium carbonate. So it's really a unique material which can be used also as a very good limestone filler. So this is one. You can say this is one of the elements in the FutureCem technology. And then the other thing is the clay, which you also see here, which is the Danish plastic clay, which is a clay type which we have actually quite a lot of in Denmark. We have a band in the middle part of Denmark stretching all the way from the west to down to Lolland, which comprise this kind of clay, which is a clay mineral or clay rocks comprising about up to 95% of clay minerals. So this is an ultra pure clay. It's not a kaolin, it's very much magnetic clays. So it's somewhat different from what we use for producing of mesokaolin. And the technology, which is very similar to what the Swedish people call LC3, is basically that if you mix the calcined clay with the limestone, there's a synergy effect, which means that you get a higher strength than you would have had if you used the calcined clay alone, or if you used limestone alone. And this, what I show here, is in fact one of the first tests we did. We tried to do some tests where we had either we replaced 30% of the clinker by this calcined clay, and you can see a picture here of the type we used. And then we added some limestone, and there was a clear synergy effect. We get these carboaluminates which actually react together. So there is an increased strength compared to what it would have been otherwise. And this is really the basic of the technology that enables us to reduce the clinker content more than we would have been able to do if we'd used just the pure calcined clay. A little bit about how this cement was developed and why we did it in Denmark. And the background is actually goes back to the start of the 90s. And that time, all of a sudden, we got a lot of competition in the cement market. I don't know, some of you can, if you're old enough, you can remember at a certain time there was not very much competition. But then everything changed, the price went down, and we had to do something in order to reduce our costs and perhaps even increase the potential. And we did a lot of tests, tried the limestone, tried all sorts of other things like crushed bottles, volcanic ash, whatever we could get. And then we actually came across the synergy effect that showed us this was interesting. But what happened was that the actual limestone cement was good enough. We put that on the market, and therefore we put the other stuff in the cupboard and waited to better times. And those times, you can say, came in the after year 2000, because there the consciousness of climate change actually was much, well, that's when that issue was developing. We were seeing the CO2 allowances being introduced in the EU, And we need to do some development which could reduce our CO2 footprint in the cement. So we took the old technology out of the cupboard, and we started a number of projects which was co-funded by the Danish state. And you can see the first one, which actually the project we call FutureCem, was done in cooperation with the Geological Survey of Denmark and Greenland, the University in Aarhus, the University in Aalborg. And that was actually, the purpose here was to, you can say, document the basic technology, but also further develop it. And at that time we submitted this patent application, which eventually became the FutureCem patent. Then the next step was a project which was called SCM, which was together with FLS. And FLS is a Danish company which produces cement machinery. And they were interested in developing how to produce such a material. So we had this project, again, supported by the Danish Advanced Technology Foundation. And that actually led to the first full-scale test of the project. Then you can of course say, and then the next step, the last step, was the green concrete project, which was dealing with how to actually use this material in practice. And you can say, why did this take so long time? But this, it was really because in the meantime we got the financial crisis, and that more or less meant 10 years delay in developing of, you can say, green cement types. Because the attention switched from environment to actually recreating growth, recreating the market. The bottom went out of the CO2 prices. So there was not much push for green products. But that really changed during the green concrete project, and that was very lucky for us, you could say. The green concrete project was a project which was funded by again what was then called the Innovation Fund Denmark. It was a very big project, 26 million DKK, 50% funded by the fund. And you can see all the partners inside here, and I think this is one of the very good lessons from this research project. Is really, if you want to make introduce novel cement types, novel concrete types, we really need to involve the whole value chain. And this was done here. We had cement producers, concrete producers, a contractor, consulting engineers, the knowledge institution, and even some schools to teach young people how to use these green cement type. And then we have some public building owners. And what was done here is, well, some results. We actually, and this is actually the wall, which is now, I suppose, 8 years old. That was the first full-scale thing we do. Now it's full of holes, of course, because we use this for long duration testing. And this is just a picture to illustrate the durability test which was done on the new cement types, which enabled both in the laboratory, it was outdoor exposures. We have exposure sites even at one of our deep sea harbors in order to document that actually this new cement type was a viable cement type in terms of durability. We did some full-scale tests. There was this road bridge. There was some the new concrete laboratory, the Technical University, was made partly after the FutureCem. So that actually led to that we, on the 1st of January 2021, could introduce a new cement in the market. It was certified according to EN 197.1. It was accepted as a cement type in the Danish national application document to the European concrete standard. Actually, that took a year of testing in order to have that done, to show compliance or to show equivalence with the traditional cement types. And here is actually the specifications of the FutureCem as it is today. And really, it is a CEM 2 BM QLL 52.5, so that is actually a rather high strength cement, even though we have 35% clinker replacement. Our one-day strength is slightly lower than the normal EOPC, which is the main cement type until now in Denmark, but the 28 strength is very, very close. You can also see the alkali content is equivalent to the standard cement. We can use it in ready-mix concrete. That's the main market as it is now because of the rather low one-day strengths. But it is also possible to use it in concrete elements. And there are projects done here. They're not too happy because they prefer the concrete element produced prefer higher early strengths, but they have ways of doing it, like heating the formworks, etc. It's been used in a number of big constructions already. I would like to mention this because this is actually the big headquarter, and BIG is a very big architectural firm led by Bjarke Ingels, which is quite well known. And they're building a new headquarter, and they wanted this to be 100% green, so they selected FutureCem as their cement type for this. So this is actually a good launch. For the environmental impact, the EPD for the FutureCem, it's a little bit below 600 kilos CO2 per ton of cement. That is equivalent to about 30% reduction compared to the CEM1, which is the main cement type, and this can be used more or less equivalent to that. Of course, it's higher than like a slag cement, because here we have the disadvantage that we're using a natural raw material which needs to be processed. And this is really one of the issues that we have in the competition. You can say we're up against industrial raw materials, which in fact comes from polluting industries, but because of calculation methods actually turns out with a lower CO2 footprint. We did some calculations on what would that mean in a building, and this is one example from an apartment building. We had a reference. We looked into the FutureCem, but also a FutureCem in the future, where the cement, where the fuel for the production was switched to biogas, and that means more or less zero CO2. And what we could achieve was in the building a 27% CO2 reduction compared to the traditional Danish technology, which would be fly ash and CEM1. But you can also see that for the whole building, the savings is smaller. And that's of course because the building consists of a lot of other things like concrete. Very often it's said concrete is really the big CO2 sinner in the building, but obviously there are many other things inside the building. So it's just a point which we would like to point out also. Okay, what about the future? Now we have already heard about standards. So one of the future is a new standard, EN 197/5, which is not harmonized. And this is again this horrible argument between the European Commission and the CEN, the standardization organization, which has more or less stopped harmonization of new standards. So this is non-harmonized standard. But the interesting thing for the calcined clay limestone cement is that the new standard will enable us to increase the clinker replacement from 35 to 50%. So this is you would say, the opportunity we have. And to do this, we have started yet another project, which is called Kaliste. It's a rather strange name but Kaliste sounds good, so we have to find a title which suited that. And the subject of this project is, again, to develop either a second generation of the FutureCem with higher early strengths and still 35% clinker replacement, or a third generation where we increase the clinker reduction with 50%, and then properties which is similar to the present FutureCem. And what is very important here is, because that's what we didn't do in the first green concrete, we need to do all the documentation which will enable the new cement type, the EN 197.5, and this cement to be accepted in the Danish concrete standard. This project runs to, I think the next shows this, yes, project runs 4 years. So, and we are finished in a little less than 2 years. And there hopefully we will have this new cement type. Again, we can see we try to have a very, very broad project with a lot of partners from the whole value chain. And then we hope that this will enable us to get a quick to rig implementation. Just to stop this, it is the intention of Aalborg Portland to have this cement type as the main cement type by 2030. It will be the part of the CO2 reduction effort of our company, or the company in Denmark, which would be to reduce from 2.3 million tons of CO2 to 700,000 tons, using various means. We are also introducing the cement type in our group company in Belgium, and we are looking into other parts as well. And as you know, LC3 is a project which is a cement type, which is more or less the same technology. So it actually means that this technology is relevant on a global level. It's a technology which I believe actually will contribute a lot to make the cement production less CO2 intensive in the future. So I think this is what I could say.
Tusen tack.
Selv tak.
Vi hinner med en fråga.
Ja.
Den är ställd på engelska.
Ja.
Du får svara hur du vill.
Ja, altså, det er vi sådan set nok. Vores store udfordring er i øjeblikket, at vi har egentlig ikke særlig meget FutureCem at gøre med. Fordi at vores produktionskapacitet har svært med at følge med, hvad det hedder, det der kan sælges. Så vi vil gerne samarbejde, men vi skal bare lige have det her afpasset med, hvad vores muligheder er.
Okej. Vi får jag välkomna. Det är ganska många frågor och det är jättekul att se. Vi ska försöka se till här att få dem besvarade i efterhand här. Vi får fråga snällt de som har varit här. Hoppas det går bra. Det var många frågor och vi gör ett försök helt enkelt och återkomma.
Super.
Ja, tack så mycket. En applåd.
En satsning som vi gör här i Slite, den kommer vara nödvändig för att samhällsbyggnadssektorn ska kunna bygga fullt ut klimatneutralt. Det är ett stort omställningsprojekt. Vi ska i princip bygga nästintill en ny fabrik till fabriken för att kunna omhänderta uppemot 1,8 miljoner ton koldioxid varje år.